Today we are going to talk about artificial intelligence through my channel AI Nexus. I'm Dr. TV Geeta, and in this video we're going to talk about classification versus regression in a very simple manner. So first let us talk about classification. Classification is a supervised machine learning technique where the output is discrete categorical labels like spam, not spam. So the teacher in the case of classification teaches the computer what are the inputs and what is the label associated with it. So the classification is actually learning the boundaries between categories or classes. Examples are email, you can classify it as spam, not spam. Then medical, you can classify disease, no disease. It need not necessarily be only two. For example, an image can be classified as a dog, cat, or a bird. And student results can be classified as class or field. Now, why does this matter? You can use classification in fraud detection, customer segmentation, quality inspection, medical screening, document sorting, and so on. Actually, what problem are we solving? We are solving decision making. Which group does this particular input belong to? So real world image tagging systems like Google Photos used this classification to tag photos. Then how does it work? It works by giving the model label samples, input and output. That's supervised learning. It learns the patterns that separate the categories, so the decision boundary between the two distinct groups, and then tries to find out this input belongs to which region or where does it fall into. And it predicts only the class, it predicts the class of the new unseen label, that is input with unseen label. But whatever answer you get, whether it's a probability or not, here it only categorizes it as discrete labels. So mathematically it is like having an if then else rule, and often even if you use probabilities, it picks the most likely one. See, if the probabilities, for example, of fraud is 0.92, we will say that it is fraud. And how to measure success? One is accuracy, how often was it right? Then precision of all the label ones that have been labeled positive, how many were actually positive? That is, are you avoiding false alarms? Another one is of all the actual positives out there, how many did you actually identify? That is avoiding mishits. Now classification is, as I already told you, separating categories. So you want to separate categories based on the students' attendance as well as study hours. And there is a decision boundary you have to find. The goal is not to predict a number, it is to predict where it falls in class A or class B, here pass or fail. So the model actually tries to separate data into two regions, class A, boundary, class B. That is classification. Now we will talk about some examples of classification. One is customer churn detection. Churning is that whether the customer will leave you and go to some other service. So raw data you normally take for this customer demographic, purchase history, all that you can take from transaction data, app, website activity logs, subscription duration, payment records, and so on. From this, the system will develop a feature parameter like engagement score, days since last purchase, complaint frequency, usage consistency, and so on. And this is given to the, and of course you will also have the output label. So this is given to the classification model, and the model understands this. And then when it's given a new data without the label, it is able to predict whether the customer is likely to stay, be loyal, or is going to churn. Okay. Another example is identity fraud detection. Here you have real world transaction data, raw data like login location, transaction details, account behavior history, password reset, the number of times, attempts, time and access patterns, and the features are created out of this. Unusual location stores, score, transaction anomaly indicator, fail login frequency, behavior deviation score, velocity and time pattern signal. The features are decided by you, and the input data you need to take are decided by you. Then this features along with the label is given to the classification model and used for fraud detection, whether it's a legitimate transaction or it is fraud. Next, we will go into regression. Regression is also supervised learning method, but here we give a quantity, a continuous numerical score. So here the regression, what is you're teaching a computer to estimate a value, learning numerical relationships so that you can predict future values. So example, house price prediction, you're actually predicting an amount, then weather forecasting, exam score prediction, and sales forecasting. So all these are actual numbers. So it matters because forecast demand, plan budgets, estimate risk, and predict trends. For all this in business, this can be used. What problem are we solving? Regression is actually quantity estimation. What numerical value should I predict? So the model learns the relationship between the variables. Real-time predictions in apps like Uber actually use regression style learning estimation to estimate the riding time. Okay, and then regression, how does it work? The model is trained on label examples. Many input and output pairs will be there, and you will fit a pattern to this input output pairs, and it will learn a continuous mathematical relationship between the input and output. Given these features, what is the best numerical value I can find? Okay, so use that pattern to estimate new values. Here you have only continuous numerical values has to be the answer. So you're actually what you're doing to the data, input and output, you're trying to fit a curve or a line, and the output is a real number. So for example, it actually measures the distance, you can say in one sense, of what was predicted and what is the true value. Remember the true value is there because it's supervised learning. So suppose the true value is 50 and you predicted 48.2, then there is an error of 1.8. The job of regression model is to minimize this error. So how do we measure accuracy? We are predicting numbers, so we measure how far the prediction was from the actual value, the error. So there are two types here. Mean absolute error, where the average distance between the predicted and the true values are found, or the squared error, where the squares the error such that you penalize larger misses with higher values. So this is regression. Then we'll see an example. So for example, you're given experience and salary, and you try to fit a line. When you're given for example, a new value 6 years, you project it onto this line and find the value. Here we get 42,000. So it is as we already told, it's a continuous value estimation. Now let's take example, population growth prediction. So again, you give it historical measurable quantities like past population count, birth rates, death rates, migration statistics, economic indicators, convert that into population growth rate, net migration status, the balance between death and birth, trend over time, and so on. And you give this in to the regression model, and you get a numerical prediction. And by the model actually fits a curve or a line, and then given a new input, it will try to find out. In this case, it can give an example of 12.8. Another one is advertising popularity detection, very useful for business. So raw campaign and audience information like ads, spend amount, platform channel used, audience demographics, and then time and placement, and past campaign performance, and then features, appropriate features are calculated from that, like spend efficiency score, target audience match level, engagement trend, and so on. These are taken, given to the regression model along, and then it's plotted on a curve. Or curve is fitted, and then given a new value, it predicts that there will be 78% engagement. So now let's look at the comparison between classification and regression to just summarize what we've learned. So here the concept is mapping of values to predefined classes. That's what we are doing. Here we are mapping the values to continuous output. Goal is assign class. Here is estimate quantity. Here output is discrete value, yes, no, or class A, B, C. Here it is a continuous value. It's a numerical value. Question type is which class. Here we are going to ask how much, how many. Nature of prediction data here is unordered. Here it is a little ordered because we are fitting it into a curve. Typical evaluation is accuracy, precision, recall. Here it is error. Okay. And then decision boundary here there is not. It is not applicable. There is no boundary. It is only an overall fitting of curve. And example prediction is fraud, not fraud. Here it could be house price. Some example algorithms are decision trees, SVM for classification, and linear regression is an example of regression.